AFA's Central Florida Martin H. Harris Chapter President Todd Freese.
Thank you. 36 years ago, our chapter established this great symposium and has been working closely with AFA to keep it one of the premier professional development events for airmen. Today is our honor to participate in continuing that great tradition by hosting this session. I am pleased to introduce our keynote event to conclude our symposium. Lieutenant General John Thompson is responsible for approximately 6,000 airmen worldwide. He commands an annual budget of over $7 billion to support the research, design, development, launch, acquisition, and sustainment of satellites and their associated command and control systems. Accompanying General Thompson is global innovator Elon Musk. In 1983, he taught himself computer programming at the age of 12, sold the code for a basic-based video game called Blaster for approximately $500. And in 1995, he started Zip2, a web software company later renamed PayPal in 2001. But more recently, you might know him for revolutionizing electric cars as CEO and product architect of Tesla Motors. Development, that's all the Tesla owners. Development and manufacturing of advanced rockets and spacecraft for missions to and beyond Earth orbit as founder of Space Exploration Technologies, SpaceX. And conceptualizing high-speed transportation known as Hyperloop. And if you haven't heard some of these quotes by Elon Musk or Muskisms, let me introduce this one. Here's my first one. And when I first read it, I thought, while it applies to innovation, it's also written into the contract of every airman in this room and every man and woman who has served. The quote is, if something is important enough, even if the odds are against you, you should still do it. Now, looking back to our speech this morning by Dr. Roper, when he talked about innovation, one of the Muskism quotes is, failure is an option here. If things are not failing, you are not innovating enough. But my favorite quote, I would like to die on Mars, just not on impact. General Thompson, Mr. Musk, over to you. Thank you. Welcome.
Well, Elon, thanks so much for being here today. As you know, and many people in the audience know, we're reprising a fireless fireside chat that we did at Air Force Space Pitch Day back in November. I ran into General Goldfein, the Chief of Staff of the United States Air Force, this morning, and maybe I was being a little bit too confident, but I said, hey, I think that we did such a good job together at Space Pitch Day that Elon and I got invited back for a much bigger audience, higher stakes and everything like that. And General Goldfein looked at me and went, no, JT, you guys are going to do it until you get it right. So we're going to talk a little bit today about innovation. For those of you in the audience that nothing that was introduced about Elon made it to the prefrontal cortex, and you're like, I still don't know who this guy is. You may remember him from the movie role in Iron Man 2, or the TV show The Big Bang Theory. You may remember him, if you're old like me, when you used to have to do dial-in modems. You may remember how PayPal actually worked over a dial-in modem.
Yeah.
And if, just in case you've had your head in the sand for the last decade, you absolutely have to know him for Space Exploration Technologies, SpaceX, a tremendous partner of the United States Air Force in the space business, and for Tesla. So for just for grins, this fastest growing auto company on the planet most amazing capability. And when Elon pulled up, he and his entourage in 3 different Teslas this morning. How many Tesla owners do we have in the audience? Stand up if you're a Tesla owner. All right. Very nice.
The Secretary.
So, Elon, you and I have talked about whether the Air Force is the most innovative service. The Department of the Air Force now, the last time we interviewed, it was just the Air Force. Now we're the Air Force and the Space Force as part of the Department of the Air Force. Most of those people who stood up were in the front row. We have a lot of first adopters here in the front of the audience, apparently, or maybe those are the folks that just make the most money. Who knows? Okay, so again, today's discussion is about innovation and how we can make the Department of the Air Force the most innovative department within the Department of Defense and perhaps across the United States government. So, Elon, question number 1. When you put a weapon system or a product into production and you start delivering it to your customers, very, very frequently there is a pushback within the production organization that, you know, we don't want to change that product too much. It's successful. We have a lot of legacy systems that we're responsible for in the Department of the Air Force. There is a lot of reticence at times to incrementally improve or add new capabilities to those systems. From the context of Tesla and SpaceX, how do you motivate your workforce? How do you work with your customers? How do you work with technologists in your ecosystems, your various ecosystems, to try and make sure that products don't become stagnant and they continue to incrementally improve over time?
Sure. Well, first of all, thanks for having me here. It's an honor to be here with you and with everyone else from the Space/Air Force. And I've obviously had a long relationship with the Air Force and very much appreciate the support over the years. So I just want to make sure to say that. And look forward to doing a lot of interesting things in the future. I think it's actually, it's cool that there is, that the creation of the Space Force is happening. I think it makes sense that there's a major branch for every domain, you know, with that, so the domain of space and the domain of air are both important, but I think space is certainly a medium of its own.
Sure.
I think there's some very exciting things that are possible. If I may just say, like, what the public wants, I think, and actually I'm pretty confident that the public does want this, is Starfleet Academy. You know, like, yeah, like how do we make Star Trek real? You know, that'd be pretty amazing. I'd love that. You know, so I think like the fastest we can make sort of Starfleet real, then we should try to do that.
Well, so Elon,
yeah.
speaking for the United States Space Force, there already is a Starfleet Academy. It's the United States Air Force Academy in Colorado Springs, Colorado.
Sure. Yep, I've been there. I've given a talk, and you know, the first launch of Falcon 1, we had a Falcon sat from the Air Force Academy. That rocket blew up, but but then the funny thing is that it blew up. Like, here's this truth is stranger than fiction. The satellite was shot through the fairing, arced through the air a couple hundred meters, and then plunged through the roof of a tool shed, and then landed on the floor. And was actually in reasonably good shape. I mean, for crashing through the ceiling, but you know, you're like recognizable, you know. And we gave it back, and so we've not lost one of your satellites.
So from a SpaceX perspective,
buff it out.
a partial mission success.
Yeah, it's like, well, it's not lost. I'm just saying, it's a little bit worse for wear, but but here you go. But then we subsequently launched future Falcon sats to actual orbit. That was great. So I think we can go a long way towards making Starfleet real and making these sort of utopian or semi-utopian futures real. But it will definitely require radical innovation. One can't get there by incrementally innovating expendable boosters. There's just no way.
Yeah.
So I think we need to push for radical breakthroughs. And if you don't push for radical breakthroughs, you're not going to get radical outcomes. And that does mean taking risks. And common sense that if you take a big risk, in order to have a big reward, there must be a big risk. Most of the time, you cannot find big reward for small risk. Those are rare. So you're going to have some proportionality with the risk and reward. But if the goal is important enough, and I think increasingly the goal is important for many reasons. The goal of having the best technology in space, that is, I think, going to become increasingly important, and it'll be increasingly important for the United States to use what I think is its greatest attribute, which is invention and innovation, to create space technology that is the best in the world. And in fact, I think if the United States does not use breakthrough innovation, it will fall behind. Yeah. So I think this is not something that was a risk in times past, but I think is a risk now.
Okay.
So, yeah.
Do you characterize that risk in terms of peer adversary competition around the planet? Are you suggesting that it's our adversaries that require us to be those radical innovators, or is it just we can't become complacent and stay incrementally improving our systems? We must take those giant leaps forward as a nation, regardless of the competition.
I think there's I have zero doubt that if the United States does not seek great innovations in space, it will be second in space.
Okay.
With as sure as night follows day. So it is a big deal. But this is a very innovative. There's no country more innovative and inventive than the United States. So it's just important to use that attribute. That's the ace card.
Okay.
Yeah.
And since it seems like we're going down the geopolitical path here on the questions, how does the United States as a nation maintain that innovative edge, that ability to invest in things and take those risks? What kind of governmental policies or processes do we have to encourage the right kinds of behavior in your view?
Well, I think having outcome-based procurement is actually very important.
Okay.
So you say, like, this is the outcome that is sought, and whoever can achieve this outcome or achieve this outcome to a greater degree, that company that's who the Air Force will do business with, and will procure the thing that is radically innovative as measured by what is important for leadership in space. I mean, I do think it's absolutely fundamental to achieve full reusability in access to space. This is the holy grail of space. At the point at which you have full reusability for orbital rockets, then you have a profound advantage over anyone else. It's profound. It would be like if in the Air Force, if you had planes that could be used once, and or if you had multi-use planes that could be flown over and over again, like normal, and all your adversaries had single-use planes, that would be no contest. It's the same thing in space.
Okay.
Yeah, this is extremely fundamental. So the cost of propellant is typically on the order of 1% of the cost of the vehicle, or less. So if you have a vehicle that is, say, I don't know, locks kerosene, like Falcon 9 or something like that, you know, it's the oxygen and the fuel are, yeah, maybe $500,000 or something like that. But then, depending upon the mission price can be anywhere from like $60 to $100 million. So now Falcon 9 is a partially reusable vehicle, but not fully. The vehicle we're working on right now, which is quite difficult, is Starship. And yeah, that has the potential for full reusability. But I think it would be great to have other companies as well that are doing full reusability. I think competition is a good thing. Mm-hmm. It may seem at times that, you know, shouldn't we focus all our efforts on one system and rather than divide them and have two competing systems? Like, you know, not to cause controversy, but like, in my opinion, like, Joint Strike Fighter should be a competitor to JSF. That's I know it's a controversial subject, but you know, I think it's not good to have one provider. It's good to have competition where that competition is meaningful, and somebody can actually lose. That, like, you know, so then so yeah.
Okay.
Yeah.
So in radical innovation, obviously the workforce is a really key component of that. I mean, during your PayPal days, you were actually doing coding, mm-hmm. right? But in SpaceX and Tesla, they are so large that Elon can't do everything. What sort of things do you think about in terms of motivating a workforce like we have in the Department of the Air Force that will help them become more radically innovative? What sort of things do you look for in people or in processes that make the workforce better?
Sure. Well, I think the massive thing that can be done is to make sure your incentive structure is such that innovation is rewarded and lack of innovation is punished. There's got to be a carrot and a stick. So if somebody is innovating and making good progress, then they should be promoted sooner. And if somebody is completely failing to innovate, not every role requires innovation, but if they're in a role where innovation should be happening and it's not happening, then they should either not be promoted or exited. And let me tell you, you'll get promoted. You'll get innovation real fast.
Okay. The stick.
Yeah. It's like, how much do you want?
Yeah. So does that carrot and stick approach help, do you think, people be more risk averse or less risk averse? Well,
when trying different things, you've got to have some acceptance of failure, as you were alluding to earlier. Failure must be an option. if failure is not an option, it's going to result in extremely conservative choices, and you may get something even worse than lack of innovation. Things may go backwards. If what you really want is you want reward and punishment to be proportionate to the actions that you seek. So if what you're seeking is innovation, then you should reward success in innovation, and only there should be minor consequences for trying and failing. There should be minor. With significant rewards for trying and succeeding, minor consequences for trying and not succeeding, and major negative consequences for not trying.
Okay.
So if you have that incentive structure, you will get innovation like you can't believe.
Okay.
Yeah.
So you've talked at Tesla shareholder meetings and in various interviews that you consider the machine that builds the machine
Yes.
to be just as important, if not more important, than the machine itself.
Yeah.
So we talked about the workforce aspects. Are there processes that you use within your company that are parts of that machine that you think are particularly valuable for innovative, radical change?
Well, what I mean by the machine that builds the machine is that designing the production system of a new product is, I think, at least an order of magnitude or 2 orders of magnitude harder than designing the initial prototype.
Yeah.
I think, like in America, there's been less importance in modern times placed on manufacturing, and I think this is a mistake. Like at this point, I would really classify, and in fact, I sent an email to SpaceX just saying this. Like, at this point, I think designing a rocket is trivial, just trivial. There's like tons of books you read them, you can understand equations, you can design a rocket. It's real easy. Yeah, if you say like 2-stage, 2% of your liftoff mass to orbit, just to design something like that, piece of cake. Now, if you say you want to go into production with that, or if you want to actually make, let's say the next step is you want to make even one of those things. Okay, now making even one of those things and getting it to orbit is hard. But the designing of it is not hard. The making of even one is hard. The making of a production line that builds and launches many is extremely hard. And then the next level beyond that would be creating a fully reusable system and having that be in volume production and volume launch. That's super hard. But by building a machine that builds a machine, I mean creating the production system, and I keep emphasizing to SpaceX, the hard part is making it and making lots of them and launching frequently. Because reuse must not just be, it can't be reuse like the shuttle. It's got to be rapid and complete reuse. So the shuttle was a case where the reuse was very slow and it was not complete. The main tank was lost every time, and refurbing the shuttle between flights was extremely expensive. It's not even clear whether it was worth recovering the booster shells from the ocean. So just like an aircraft, the rocket must be rapidly and completely reusable, and then you need lots of them. And then I've been sort of just doing back of the envelope of what's needed to establish a self-sustaining city on Mars. And these are like big numbers, but I think you need on the order of 1 million tons to the surface of Mars, useful payload, something like that. Because we sit on the top of a massive base of infrastructure, or the economy is, you think of all the things that are mined and then refined, and then there's many steps in the refinement. And in order to produce like your phone or your toaster even, there's a vast base of industry that was required to produce even a simple household item.
Yeah.
It's very difficult. So, so you've got to recreate that on Mars. So 1 million tons on Mars means, and we're just talking orders of magnitude here. And hopefully it's not 10 million tons, and hopefully maybe it's less than 1 million tons, but probably not 100,000 tons. So that means you need to get about 5 million tons to Earth orbit of useful payload. So you're talking like so essentially, unless you have a launch system that is somewhere in the megaton per year range to orbit, it's not relevant.
Okay.
Yeah.
So Starlink, as you're scaling to build more and more Starlink satellites to go on more and more reusable rockets, what are some of the challenges you've had to overcome in Starlink production so that you can perfect that machine that builds the machine?
Yeah, Starlink production is going well, actually. That was a hard thing to get right. We had many iterations on the Starlink prototypes, and then, as I said, then building the Starlink production line was, I don't know, 1,000% harder than designing the satellite to begin with. But it is important to have like to design for manufacturing and have a tight feedback loop between the design of the object and the manufacturing system. So when you design the object at first, you don't realize all the parts that are really difficult to manufacture, and so having the manufacturing system and the design bring those up at the same time, so that you're actually in the beginning making a thing that you know is wrong, but you're actually figuring out what's hard to manufacture.
Okay.
That's the real problem. So we brought up the Starlink production line before we actually had the design finalized, which is actually the right thing to do. And then we discover, oh, there's all these things that in the design that are very difficult to make, and so therefore we must change the design. And the satellite ended up having the same capability, but just was very